Okay, we're going to try to keep this one a little short. Today we're going to talk about how to find the area of a parallelogram. So we've used that word a lot over the last few days. My assumption is you're sort of comfortable with it. And so you're going to write your name, I'm assigning this video on the 1st of February, and it's going to be due on the 2nd of February. Okay, so a parallelogram is like a rectangle for a lot of reasons. They both have two sets of parallel sides. But the thing that's actually most significant for us is that the two sets of parallel sides mean that, and I've hinted at this before, that opposite sides are congruent, okay? Opposite sides are the same, right? And you know this about a rectangle, but it might not be obvious to you about a parallelogram, and it's very relevant. Okay, so let's label the parallelograms appropriately. Every parallelogram has a base and a height. You might have called it something different before. So this is the base, right? The line segment that is the base of the parallelogram. Now, the height of the parallelogram is a line segment that meets the base at a right angle and runs from one base to the other. So it meets at a right angle. And if you're not super comfortable with the idea of what a right angle and 90-degree angle is, we'll talk about that on our hands-on geometry day on probably February 10th. And so this is the base and this is the height. Now, you're going to ask me a really good question. You're going to ask me, can I turn it sideways and make this guy the base? And the answer is yes, but it's not going to be quite as easy to draw a line at a right angle from one side of the polygon to the other. So we're usually going to try to do this the easiest way possible. But every base has a height that goes with it, that is its buddy, that meets at the right angle. And that's the big important part of a parallelogram. Okay, so we're going to emphasize this. This is the base of the parallelogram. And that is a line segment with a particular length. And then the height goes up at a 90-degree angle, straight up, all the way to the top of the parallelogram. But the big thing is that it has to be at a 90-degree angle. And obviously those aren't the most beautiful straight lines we've ever drawn, which is why we're going to go to the next section where Okay, so I made this look a little different because I want you to see that there's actually grid lines behind here. So we're going to start talking about how we can find the area of a parallelogram. Okay, and we're going to try to talk about finding a shortcut. So if you look very closely, you can actually see here that there's grid lines. Okay, so this parallelogram has a base that actually runs for two boxes. We're going to call it 2 units. Okay, the base equals 2 units. Right? Now, if we were going to ask, what's the area of this, we would have a bunch of ways to figure it out. Now, the other thing that we need to know about this that is very relevant is that the height here is 1 unit. Okay? Now, if we were going to count boxes, which is what you do at the beginning when you're young, you would say that this was the first box. And you might say that this is a half a box and this is a half a box, right? Well, there's another thing that's really relevant here that I'd like to point out, which is that this piece fits really beautifully in over here, okay? And that's a really funny thing about parallelograms. I didn't draw it perfectly, so there's a teeny bit extra. But a parallelogram, basically, you could always cut off either one piece or more than one piece and essentially reassemble it as a different shape, right? This is a parallelogram, a standard generic parallelogram. But as soon as I cut off that side and put it over here, it looks a lot more like a rectangle. A rectangle that has a length of 2 and a width of 1. So that's going to be very interesting to us. So we counted the squares and we said, it looks like it's about 2 squares. We rearranged it as a rectangle. We said, that looks like it's about 2 squares. So I think we're very comfortable with saying that the area is 2 square units for this one. Let's take a look at this one. Okay, it's a little bigger, the one on the right. Let's do our guessing first. Well, that's 1 and that's 2, right? And what about these and these? Well, this is more than half of 1, but this is less than half of 1. This is more than half of 1 or less than half of 1. So I'm pretty sure you can come up with a good estimate right now of around 4 square units. Now let's see if rearranging it as a rectangle will help. You see, our base is 2 square units. I'm sorry, it's 2 units, 2 plane units. Bases can't be square units until we do 3D figures. And our height here is also, right, meets at a nice right angle, is also 2 units. So the question is, can we reassemble this guy to look like a rectangle? And we're going to sort of be pulling this trick on. Okay, so what I did here is, because I couldn't draw something that looked super nice, I'm picking this up and I'm putting it over here. But you have to imagine that this guy is disappearing with it, right? And if we look at this, ignoring this piece that I have decided to sort of kick out, this rectangle that we have reassembled from our parallelogram is actually 2 by 2. It measures 4 square units. So we have a parallelogram with a base of 2 units and a height of 2 units, and it can be reassembled into a rectangle with a base of 2 units and a height of 2 units. So that's really, really interesting to us, and that brings us to our next rule. So the rule for area of a parallelogram is, as long as you find the correct base and the correct height, they have to fit together, you could always multiply them. Base times height, base times height, base times height. It's just like a rectangle, only you don't have to imagine rearranging a rectangle. So this is a base of 9 and a height of 4. We could take this piece and put it right there. And so base times height is 9 times 4. We always actually write down in math. 63 square centimeters is our final answer. Okay, this one's going to require just a little bit more calculation. Our base is 6.3. Our height is 2.1. We could physically pick that piece up and put it there, chop it off, stick it there, and we would get a rectangle. So 6.3 times 2.1. Let's see if we can do this quickly. 3, 6, 0, 6, and 12. And we need 2 decimal places. So it's going to be 13.23 square meters. Okay? And right, that fits our estimate because 2 times 6 is 12, so that is about 13, makes sense. So it's very, very straightforward as long as the question is straightforward. We're going to talk about 2 different more challenging situations, and one is working backwards. Okay, so what if they give us the area, right? If we know that area is base times height. So we said before, if going forwards we multiply, then going backwards if you said divide, you said correctly. So if the area is 98, so we can take the area, we can divide it by this base here, and we should get the correct height. Because this times this is that, right? So it's a fact family, that divided by that. Area divided by base equals height. Okay? So this, if you look at this like it's a fraction, I mean, it's an annoying long division, but if you look at it like it's a fraction, it's actually not hard to simplify it. First, I just divided top and the bottom by 2, and then I divided top and bottom by 7, and I got 7 feet. And that is in single dimensional units because it is just a height, and a height is 1 dimensional. Okay, so now we're going to start getting into the first type of challenge, which is extraneous information. So we're working backwards. We have an area, we have a height, we have this number here, and we have B. So the most important thing for you to do is to realize that this is the number you care about, and this is the number that you don't. We'll talk more about that on the next slide. So we have to do 1293. 12 and 93 hundredths of a centimeter divided by 2.45. That's going to give us the correct answer. If we divide by 2.98, we're going to be less successful. So I'm sure you all wanted to spend your evening watching me do long division. It's going to be to the nearest hundredth. So what that means is that I am going to stop when I get to that point, okay? So we go boop, 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 like we learned in Unit 2. We're going to multiply both by 100. So how many times does 245 go into 129? That would be 0. How many times does 245 go into 1293? That would be more than 0. Probably about 5, because it's going to be 245. I always like listing multiples. You guys know that. 490, and then something, then 980. And so 980 plus 245 is going to end with a 5 and a 2 and a carry the 1, that's 10. So that's 1225. So unless I did my math wrong, which I will check on a calculator because I don't want to steer you guys wrong or waste your time. I need to put a 5 up here. So it's going to be 5 point something centimeters, right? And 5 times 2 is 10, so that makes sense to us. So now I put 1225 here. I have I have to borrow and 13, so that's going to be an 8 and a 6. We bring down a 0, 680, so it's going to be that number that's in between here. So what is 490 plus 245? Well, it's going to end in 35. Carry the 1 is 5, and it's going to be 735. Is going to be halfway between 490 and 980. So this is too large, so it's got to be this one. So it's going to be 5.2. 2 times 245 is 490. Then we have a 5 and a 1, and then that's 19. 190. And then we have a 1900, and that's very large. So even though it says to the nearest hundredth, we're going to stop at the nearest tenth because goodness me, this is an annoying one. I'm going to try to make the ones that I give you for homework not that annoying, and it's about 5.2 centimeters. Okay, so that was lengthy, but we got through it. The last thing we're going to do here is extraneous information. We got to get rid of it. Got to get rid of extraneous information. Okay, we have a base. Which one of these is our height? This one. This is not anything. It's not helpful to us at all. So 12 times 8. And that's going to be 96 square inches. Now, this is fascinating. It's actually true that none of this is extraneous. This is like a challenge problem. If you are not a challenge person, you wouldn't be expected to do both steps of this at the same time. We've got an area. We've got a height, and we've got an extraneous piece of information, or is it? Because if we do 2508 divided by 44, then we are going to get a number, and that number, oh, that's way too big. And that number is going to, I'm using a calculator because these numbers are awful. That number is going to give us a very useful piece of information. It's going to tell us the side length. And then what is the question asking here? It's really always helpful to know what the question's asking for here. It's asking for the perimeter. How do I find the perimeter of this polygon? I add up all the sides. So I just have to do 48 and 48 and 57 and 57. That's 105 times 2 is 210. And the final answer is 210 centimeters. So this is much more of a challenge problem. And if you're a challenge person, you're going to see ones that are like it. And that is the end of this video.